So hi guys, here we are. Today we are going to solve for the question. What's the question? Let me see quickly. Okay, yeah, quickly. I'm just picking up all the questions that people say this is very complicated and things like that. Okay, so this question is for the odd periodic function defined below. Find the Fourier series. Okay, Fourier series. It is between -1 and 1, and it is this is the interval for this one. These are the limits for this first point, and the second point of this one, the limits. So this is odd function. Okay. So and fx, they say fx it is -1, and fx is 1. It is 1 between 0 to 0 less than x less than 1. And here 0 less than x, -1 less than x, and x is less than 0. They said that it's an odd function. Okay, and even if you just draw this one, okay, let me just try to draw this one. This is -1 in between -1 and 0. -1 and 0 from here till here. Let me call this -1, point -1. And this is from here till here. This is 0 to it's just from here till here. So they say this is -1, fx, it means y is equal to -1, because fx is y, okay, is equal to -1. You come here and put here -1. This is equal to -1 when this guy is in between this one. So this is -1. Okay, this is a horizontal line in between 0 and -1 for x. And this guy, it is equal to 1 positive when it is 0 to 1. So with 1 positive is here. So it will be a line till this one. Okay, will be a line. So this is not that much complete. Okay, this one. So as you can see, this is an odd function. Why? It's an odd function because this guy is symmetric. It's symmetric. Okay, with respect to the origin. Okay, for even function it should be symmetric with respect to y-axis, and there is too many ways and there is another way. Okay, not many ways, there are only 2 ways to show if a function is even or odd. The first one, it is this one, it is by in the geometric way or by graphic. Okay, and you see, just compare. Okay, and the second one, it is the used one, most used. It is when we have f(x), f of minus x equal to minus f of x. If a function can accept this condition, then we can say this function is an odd function. But if a function do not accept this condition, like this one, this accept this one only, then we can say this is an even function. Okay, function like cosinus are even function because cosinus of minus x, it is equal to cosinus of x. These are even function. And function as sinus, okay, sinus of minus x, it is what? Sinus of minus x, it is minus sinus of x. Okay, minus sinus of x. So it means what? It means that sinus, this guy is a even function. Sinus, not sinus. Cosinus is an even function, and sinus is odd function. Okay, because you see, cos of minus x, it is equal to cos of x. Sinus of minus x is minus sinus of x. See, this one is odd, this one is even. So this guy is odd, even, this guy is odd. So even by graphic, okay, graphically, what is graphic of sinus? The graphic of sinus, it's always coming from here, from 0, from the origin. Okay, and this is like this one, and this one, and this one. Okay, so this area between this here and here, okay, asymmetric, are equal but different signal in this one. This area is equal to this one, but with respect to the origin. So we can say this is symmetric. Okay, yeah, they are symmetric with respect to the origin, so it means that they are odd function. But for cosinus, suppose cosinus here, we have just okay, I will just draw here down. For cosinus starts from here. When cosinus is 0, it's 1, the maximum value. So cosinus starts like this one, like in this, and it goes this way. So if you see this area here and here are equal, okay? The only difference is that they have different signal for this one, for this y, this one. So this part and this part are equal. They are equal, but different signal, okay? Because here for third, this here it is almost, let me just complete this, okay? If I complete this one like this one is a cycle. First, this is a cycle. This, if you join this and this is a cycle. This is a cycle. If you see, okay, here this will be a negative cycle of cosinus, and here it will be a positive cycle of cosinus. Okay, just like this one here, cosinus will be negative, and here cosinus is positive, only like this. Okay, so they are symmetric with respect to y-axis. Okay, this is what we mean by even and odd function. Okay, now let us solve this. Okay, let us solve this one. They said that this is an odd function. So if they say that this is an odd function, what does it mean? It means that a0, okay, will be 0, and b and an will be also 0. Why, Veloso? Very easy. See, a0 depends, okay, here, let us find what will be L here, what will be the period of this function. Just compare, here you have to compare, the period of this function will be 1. Okay, if you just compare this one, because you will compare like this one, what are the limit and this one from here, it was from 1 of 1 and 1, okay, here the limit L is 1, if you just compare with this one, minus L goes to x, and here L, this one will be 1, okay, so it will be 1 by L integration of this L minus L of fx of dx. If f is an odd function, okay, this will be all 0, okay, 0 directly, okay, just like this will be 0. And the same will be happen with this guy. Just substitute L equal to 1 minus 1 and put this one and try to solve this integration with this interval and this interval. In the end, you will end with 0. And also for this one by L, L minus L, you'll get f of x and cos of n pi x upon L dx. L is 1, just put here for 1, 1, 1 and calculate this integration. You will get 0 because f of x is minus 1 between this interval and is 1 between this interval. Just do the same, just split this one and you will get 0. Okay, this will be 0 also. But for Bn, it will not be 0. Why? Because Bn is a function that it is itself an odd function. So whenever we have an odd function, so it will be directly just find this one. So here Bn, okay, here Bn, Bn will be 2 upon L, L minus 1, minus L, okay? Sorry, just go follow the formula, it's easily. I'm just following the formula. And fx and sinus of n pi x upon L dx. Now substitute for your L. L is equal to 1. So Bn will be 1, and here 1 minus 1. Then I will get f of x, so fx. Just keep fx, okay? And sinus of n pi x upon 1 dx. Now you have to split what is this one for these intervals, okay, that are here. So it will be 1 here, and the interval will be minus 1, 0. So from minus 1 to 0, this will be minus 1, okay, minus 1. Is that okay? Yeah, just going this way, it will be minus 1, minus 1. Then minus 1, what is this? Sinus of n pi x dx. Then plus the second integration, it will be from these guys, okay, from 0 to 1, of 1 and sinus of n pi x dx. Okay, dx. Hope you are getting these points. Okay, you are. Now what we have to do, we know that a0 is 0, an is 0. We are just calculating for bn. Now let me solve this one. So here I will get integration from 1 to 0 to minus 1, or minus 1 to 0. This will be minus sinus of n pi x dx, okay, plus integration from 1 to 0, or 0 to 1 of sinus n pi x dx. Okay, these two integrations, so you just can see this one. Just solve for this one. This will be easy. This integration will be minus sinus derivative of this sinus. So just derive this one. Integration of the sinus, it is cosinus. Okay, it is cosinus directly. So if I cosinus, but it will be cosinus negative. So it will be cosinus n pi x upon this constant down n pi. It is between 0 to 1 plus integration of the sinus. Sinus integration will be negative. Okay, will be cosinus of n pi x upon n pi also. So it is from 1 to 0, and this is from minus 1 to 0. Just find this, guys. This will be positive. Okay, then you will get what? Put here 0, it will be 1. Okay, here it's positive, it will be 1 upon n pi. If you just substitute here 0, positive, put here 0, cos of 0 is 1, so 1 upon n pi. Then put here minus 1. If you put here minus 1, what will happen? This is positive, it's okay, minus. When you put here minus 1, you get minus cos n pi. You get this one, okay, minus n pi. Cos of minus n pi. So what will it be? Cos of this guy, I told you cos is a even function. It means that cos of n minus n pi, it's the same of n pi. Okay? And cos of n pi will be minus 1 to the power n. Why, Veloso? Because when n is even, suppose when n is odd, like 1, it will be negative. And when n is even, it will be positive. Okay? Because cos of, when n is 1, cos of pi, it is minus 1. And cos of 2 pi, it is 1. Then, what I can say, it will be minus 1, 1, minus 1, 1. When the exponent here is even. And when the exponent here is odd, it is minus 1. When the exponent here is even, it will be positive. So this guy is equal to this guy. So this is directly, just put here, you'll get minus 1 to the power n upon n pi. Okay? From here it's okay. Plus, now from this guy, okay? This is minus 1. Put here for 1. It will be what? Minus. It will be the same. Cos of n pi. Cos of n pi, it is minus 1 to the power n. See? Minus 1 to power n upon n pi. Then plus, okay? Then, sorry, okay, then plus not. You get minus from the formula, and here you will get also minus from here. This is minus. It will be cos of 0. Put here 0. Put here 0. It will be cos of 0. Cos of 0 will be what? Will be 1. Okay? I just not 1 to this one. N pi. Okay? So it will be 1 upon n pi. Minus and minus. Here it is minus 1. Minus 1 times minus 1. It will be minus 1 times minus 1. It will be what? Plus minus 1 to the power n plus 1. This is just potential. Okay? So this will be this and this. Then time this one and this one. If you time this and this, it will be the same. It will be plus minus 1 to the power n plus 1 upon n pi. Okay? This and this, you will get what? You will get this and this, it will be plus. Okay? Plus cos of this guy. Okay, cos of this guy will be 1 upon n pi. Okay, just add all of this. You got 2 upon n pi plus, okay, minus twice of this guy, minus 1 n plus 1, okay, and n pi. Done. Yeah, then this is your bn. And from here, you can just take out this 2, okay, 2 upon n pi, okay, 2 upon n pi, and this will be 1, okay, 1 plus, okay, minus 1 upon n plus 1. So what we can conclude in here, if this n, when this n is even, this guy will be 2 and this will be 4. For even, this will be 4 upon n pi. Okay, if n is, if n is not even, if n is odd, this guy will be, if n is odd, this, suppose it is 1 by 1, it will be positive. 1 plus 1, this will be 2, then it is 4 upon n pi. But when this n is even, suppose 2, it will be minus 1. Minus 1 minus 1, it will be 0. Okay, for n even. So what we can conclude? We can conclude this one. This is our conclusion. See, we can conclude just for the Fourier series, f of x will be equal to what? Will be only for odd expression, because when this is even, this will be 0. Okay, for Fourier series, it will be 4 upon n pi, and here goes to 1 to infinite, and this will be sinus of n pi x. Okay, this one. So this n can come here. It will be 4 upon pi, and this will be sum from 1 to infinite of sinus of n pi x upon n. Okay, this will be the Fourier series, but for the odd part, because this series will have actually 2 parts. Okay, for n odd, this is odd. For odd n, okay, for this guy odd, okay, odd. When this guy is suppose this guy is even, okay, for even, this will be 0 for n even. Yeah, so in a nutshell, we can just say that we have only, okay, we have only this Fourier series for this function when this one is odd, okay, n goes to 1, but odd when we will accept only n odd, n pi x. Okay, this will be our Fourier series. So I hope it can be helpful for you guys, and I hope you may understand this one. Thank you.